You know that amazing feeling you get right after a really good meal? Well, it turns out that feeling is just the start of this incredible process kicking off inside your body, and it's all managed by one single master hormone, insulin. So today, we're going to dive deep and break down exactly what insulin does and why it's pretty much the ultimate boss of your metabolism.
I mean, have you ever really stopped to think about it? What's actually happening inside your body right after you eat? Yeah, you feel full and satisfied, but behind the scenes, this complex, almost beautifully orchestrated process is just kicking into high gear. And the key to the whole shebang? It's that hormone we're about to get into.
And here it is, insulin. Seriously, the best way to think about it is as your body's primary energy traffic controller, right? When that big rush of energy from your food, the sugars and fats, hits your bloodstream, insulin is the one that steps in and starts directing traffic. It tells everything exactly where it needs to go to make sure your whole system stays in perfect balance.
Okay, so let's back up and start at the very beginning. What's the trigger? I mean, how does your body even know it's time to call this powerful controller into action in the first place?
Well, it's actually this really simple cause and effect chain. It all starts when you eat a meal. As that food gets digested, glucose, sugar, starts entering your bloodstream. And as you'd expect, your blood sugar levels start to go up. That rise is the direct signal. It's like a little alarm bell for your pancreas, which then responds by releasing insulin. It's really that straightforward.
So now that insulin's in the bloodstream, what does it actually do? Well, you can think of it like a master key, one that unlocks a whole bunch of different actions in your body. Let's start with what I like to call the go signals, all the things that insulin actively turns on. At its very core, insulin is what we call an anabolic, or building hormone. Its main message to your body after a meal is loud and clear. Hey, we've got a ton of energy right now. Time to store this stuff for later. And this isn't about being wasteful or anything. It's all about super efficient energy management for the next few hours.
So where does all that sugar actually go? Well, insulin's first big targets are your liver and your muscles. It basically tells them, okay guys, start pulling that glucose out of the blood. This, of course, helps bring your blood sugar levels back down. Then that glucose gets converted into a storage form called glycogen. You can totally think of glycogen as your body's quick access sugar savings account.
But wait, how does the sugar physically get out of the blood and into the cells? This is where things get really cool. Insulin acts like a key. It tells your muscle and fat cells to move these special glucose doors, they're called GLUT4 transporters, up to the cell's surface. And once those doors are there, they swing open and glucose can just flood right into the cells. It's an incredibly effective way to clear sugar from your bloodstream.
And get this, insulin doesn't just manage sugar. It's also in charge of fat. It sends a signal to your adipose tissue, which is just a fancy name for your fat cells, and tells them to start pulling fatty acids out of the blood too. Then it stores them away safely as triacylglycerols. And that's pretty much the main way our bodies store fat. So you see, this is the other critical side of its energy storage mission. Okay, so we've covered everything that insulin turns on, but believe it or not, that's only half the story. A truly great manager doesn't just yell, go, go, go. They also know exactly when to say, stop. And that brings us to insulin's equally important stop signals.
This is a point that gets overlooked all the time. The things that insulin shuts down, its inhibitory actions, are just as vital for keeping your metabolism in balance as the things it turns on. It's truly a two-sided coin.
Just think about it for a second. While all this new sugar is flooding in from the meal you just ate, what's the absolute last thing your body needs? To release even more sugar from its savings, right? So insulin basically puts a lock on the vaults. It stops the breakdown of that glycogen we just talked about, and it tells the liver to hit the brakes on making any new glucose from scratch. And why is this so critical? Well, because the simple action prevents your blood sugar from spiraling way too high. By shutting off the body's internal sugar factories, insulin makes sure that the only sugar it has to deal with is the sugar coming in from your food. It's all about maintaining control. And insulin applies the exact same logic to your fat stores. It sends a message to the body that says, hey, we've got plenty of energy coming in the front door, so stop burning our reserves. And it does this by shutting down a really key enzyme called hormone-sensitive lipase. You can think of this enzyme as the on-off switch for releasing fat from your fat cells. So insulin flips it to off, effectively locking that energy away for later. And here you can see the whole picture, laid out perfectly. On one side, you've got everything insulin turns on, storing glucose and storing fat. And on the other side, you see what it turns off, releasing glucose and releasing fat.
It's a perfect mirror image. It's a beautiful system of checks and balances, all working in perfect harmony.
Okay, so let's zoom out for a second and put these two halves together. What does this whole dual action system really mean when it's all said and done?
What it means is that the genius of insulin isn't just telling cells to store energy. No, its real power is that it does that while at the same time telling the body to stop releasing energy. It's this perfect simultaneous balance that keeps your metabolism humming along smoothly right after you eat.
And this really is the key takeaway, something that comes directly from our source material. It's not an either-or situation. Both the go signals, the stimulatory effects, and the stop signals, the inhibitory ones, are absolutely essential for keeping your body's engine running smoothly after a meal.
Ultimately, this is why insulin is so fundamental to our health. It's this beautiful, elegant dance, stimulating storage while at the exact same time shutting down release that allows our bodies to handle the constant ebb and flow of energy from the food we eat, day in and day out.
So that leaves us with one last, pretty crucial question. We've just seen how this system is designed to work in this perfect, delicate balance. But what happens when that balance gets disrupted? What if, say, the go signals are working just fine, but the stop signals start to fail? Well, that's where things can get really complicated, and it's definitely a thought worth pondering.